In this video, I'm going to show you how to graph logarithmic functions. To get started, though, I want to review what an exponential function looks like. So if you happen to have a graphing calculator, use that. Follow along here. Otherwise, you can trust that I'm doing everything just right here. So let's say that we have the function e to the x power. Here's our most generic exponential function. If you look at that on a graphing calculator, it should give you something like this. It's going to go through 1. Anything to the 1 power is always 0, so it's always passing through 1. It's going to increase exponentially in this direction. And as we move towards our negative inputs here, our negative x values, our graph is going to approach 0 but never touch 0. We're never going to be able to get an output of 0 from an exponential function. So what we say is that the x-axis becomes an asymptote. An asymptote is a line where a graph never touches. Although, I should make a little correction here. A horizontal asymptote can be crossed. Vertical asymptotes can never be crossed, and that's something that you'll discover later on in your math education there, but just trust me on that. So it's always going to approach this horizontal asymptote here and never touch this one. And that is an exponential function. Now, the inverse of an exponential function is a log function. And an inverse line of symmetry is always going to be this line here. If it were a solid line, we would say that it is this equation. Because it's just a line of symmetry, we make a dash. It's not really there. We just envision it or imagine it. Anytime we have an inverse function, they're always symmetrical across this line. So you can imagine that this is a mirror. We're going to look across its reflection. It's going to look something like this. And so a log function, in its most basic form, I suppose, do the natural log of x. If we look at that on a graphing calculator, we find that, again, it's going to cross right through 1 there, but now approach the y-axis, but never touch it, and shoot off into this direction somehow. So you can see that they're symmetrical. They're reflections of each other. And now the y-axis becomes our what's called vertical asymptote. And log functions always have a vertical asymptote. And I'll teach you a trick for how to find it or write the equation of it every time. And so the vertical asymptote in this form is going to be the y-axis, or where x equals 0. That's our y-axis there. So that's our vertical asymptote, or the equation of the vertical asymptote. This graph will never touch this y-axis. It will approach it forever. So this is just the basics of a log graph. Graphing calculators will help you graph them or visualize them a lot easier, but remember, anytime you don't know how to graph something, if you use an XY table, you can come up with the graph. So because we're using E here, it makes it a little trickier. If you want some practice with that, you can watch some of my previous videos where I use an XY table to graph an exponential function. But for this one, this is what we're going to stick to. So pull up another graph here. So we'll use another easy log function would be log base 2. And be careful when you're using an XY table for logs. It gets tricky and kind of confusing. This value is going to be your input or your x value. And so let me show you why it's confusing here. So if I say log base 2 of something is x, then what do I write out here that's an unknown? Do I use another x? We can't do that. So we could use another letter. We'll say 2 to the a. So if I use my circle method, I got 2 to the a equals x. And 1. So this ends up being your output, and this ends up being your input. So it's kind of backwards of what you would normally think about. So let's practice here. So I want, let's say I want A to be 0, or my output, which doesn't seem like that, but 2 to the 0 is 1. So 1 becomes my x value, and this A becomes my y value. So, I mean, we could use a y instead if that's easier. So we know that 0 gives me a 1. So if I do that, if I do 1, 0, I'm right here. Okay, let's try another one. Let's replace these two values here. I want another thing that makes it easy. So 2 to some power, let's say 2. So that I know that 2 to the first power gives me 2. So 1 is my y, or my output, which seems weird. 2 is my input there. So I graph 2, 1. So put your point right there, 2, 1. And go again. This time we want another easy multiple of 2. So let's use 4 in its place. 4 is going to be my x. 2 to the what power is 4? Well, 2 squared is 4. So 4, 2 is what I end up graphing. And we could do one more here. Another easy multiple of 2 would be 8. So if I put an 8 right there for my x, put an 8 right here for my x in my xy table, then 2 to the what power is 8. And that would be 3, 2 to the third. So let me graph 8, 3. You can't fit any more on our graph. Remember that if I plug in 0, let's see what happens here. If I plug in 0 for my x, is that possible? 2 to the what power gives me 0. Well, remember that that's not a possible output for exponential functions. Anything to any power is never going to give you 0. It's not possible. So our graph is going to go closer and closer to 0, but never approach it. It's never going to equal 0. And there's the rest of our graph. So there's our log function graphed. Similar to an exponential function, just reflected across that line of symmetry right there. And log functions will always be in this shape. They will always have this vertical asymptote. And what ends up happening is, as I put more and more values connected to my log here and create crazier and crazier functions, all that ends up happening is this graph gets stretched. Either it looks flatter like that, or it has more of a curve. But it's always going to have this asymptote, this vertical asymptote, and that's always going to be shifted. So let's talk about how it gets shifted. How does this graph just get moved around but keep the same shape or the same form? So for example, if I have, let's say, keep using the natural log because that's easy to check on our calculator. -1. I have this natural log here. Well, I'm going to have that natural log shape, which is similar to any other log, and I'm going to have this h and this k value, if you remember what h and k are. So my log function form is always going to be like this. I'm always going to have this. I'm always going to have a log of some base, who knows what it is, and it's always going to be x minus h there, and off to the side, sorry I couldn't fit it there, is going to be your plus k value, where h and k are going to represent your shifts. Your horizontal shift is h, and your vertical shift is k. H is always going to appear to be the opposite, or its value is going to be the opposite of what it looks like in that parenthesis there. Similar to how it's been this whole time we've been talking about h and k. So our h value for this one right here is positive 3. So I'm going to shift it right 3 units. My k value is exactly what it looks like. It's -1. So I'm going to shift it down 1 unit. If k is negative, we go down. If it's positive, we go up. If h is positive, we go right. If it's negative, we go left. So if I take that basic shape that I had and I just shift it from the origin here, I'm going to shift it right 3 units. So now I'm looking like this, and I'm going down like that. So right here, now instead of the y-axis being my vertical asymptote, where x equals 3 is my new vertical asymptote because I got shifted right 3 spots. I also got shifted down 1 spot. So instead of crossing at positive 1 here, well, I should have drawn it a little bit better there. Now my that value of 1 is going to cross right there. It's a little bit different. So that whole graph just got shifted right 3 spots and down 1. And really the most important thing is that that vertical asymptote got shifted and it's now sitting at x equals 3. Let's try one more, just see if we get it here. It's kind of tricky at first. Keep giving you those cheats, makes it a lot easier to visualize, plot quickly. This time let's take the natural log of x plus 3 plus 2. So know that your h value is going to be negative 3 this time, the opposite of what it looks like. My k value is positive 2, so I'm going left 3 spots, and I'm going up 2 spots. So instead of my y-axis being my vertical asymptote, if I shift it 3 spots, and now where x equals negative 3, that's my new vertical asymptote. And really, this equation, if you haven't noticed, is always going to be, always, whatever your h value is. X is going to be whatever the h value is. That equation right there. So that's a good cheat to know, that your vertical asymptote is going to be whatever this vertical line equation is with h in its place. Know that I'm shifting up 2 spots. So instead of this being my nice simple value there where it crosses, now I'm shifting it up 2 and left 3. So now it's going to be about right there. And I'm going to look like this. So quick, easy way to graph logs if you know this vertical asymptote cheat and your shift rules. Know that the vertical asymptote is always going to be this vertical line equation, x equals whatever your h value is. We could also talk about domain and range. Sometimes you'll have questions that ask you for domain and range of log functions. Your domain for a log function will always be open at this vertical asymptote. So it's always going to be that h value there. And over here is always going to go towards positive infinity. It's always shooting off to the right, going more positive. So the domain for this example right here, instead of h, we would use our h value, which is negative 3. And we can see our domain, our possible x values. If we plug in negative 3, it won't work. It'll be undefined. So it's everything up to negative 3, so it's open at negative 3. And always pointing to the right or going more positive towards positive infinity. If you don't remember, this is called interval notation. And for some reason, math books will ask you to write the domain in this form for log functions, as well as some other functions here, but since we're talking about logs, this is the notation you'll generally see. Range for log functions will always be going down forever. It's always going to approach this line and keep going down, and it's always going to go up forever. So your range will always be the same, negative infinity to positive infinity. The domain is the only special one there. If you know your cheat, just stick in that h value right there, keep it open, use parentheses, then you'll always get it right. Otherwise you got to use an XY table, which is slightly trickier to do. So good luck graphing logarithmic functions using either shifts and vertical asymptote equations or your graphing calculator.